Hi, welcome back. So today we'll discuss the concept of prime numbers, and we'll later be discussing a question that is taken from the year 2019 paper 1 question for E-Maths O-level exam. Okay, but before we discuss the question, let's first recap the concept on prime numbers. There are three types of numbers that are of interest here. First is prime, second composite, and third is neither. Okay, a prime number, remember what you learned in school, is one of the counting numbers 1, 2, 3, 4, 5, 6, and so on, that has exactly two factors. So its factors are 1 and itself. Okay, alright. So one example of a prime number is 3. Okay, the only way to get 3 as a product of other natural numbers is 1 multiplied by 3. So there are only two factors in the prime number 3, and that is why it is a prime number. Okay, a composite number, on the other hand, is a natural number that has more than just 1 in itself as factors. So it has more than two factors. Neither is neither prime or neither composite. So let's look at our first example, 12. Okay, look at our example 12. And let's think about the natural numbers that can be divided into 12 without having any remainder. Okay, we know it's clearly divisible by 1 as well as 12, right? What else? How about 2? Yes, it is divisible by 2 and also 6. What else? What about 3? Yes, it is divisible by 3 and 4. So you can see over here that the number 12 is divisible by 6 other natural numbers, right? So obviously it is not a prime number, it is a composite number, correct? Let's talk about 2. What about 2? 2 is divisible by 1 and itself, which is 2. So that means it is a prime number, right? And interestingly, 2 is the only even prime number. Okay, if you think about it, right, all the other even number, they are divisible by 1 itself and 2. Right, it is divisible by 1 itself and 2. So we see over here there are at least 3 factors for other even numbers other than 2. So that means the other even numbers, they are not a prime number, they are a composite number. So 2 is the only even prime number. How about 1? Let's see. 1 is divisible by 1 and 1, right? So it is the number of factors of 1 is only 1. So it is neither prime nor composite, right? Interestingly. How about 19? 19 is divisible by 1. It is also divisible by 19. By any other thing in between 1 and 19 that is divisible into 19 without any remainder. 2, 3, 4, 5, 6? No, nothing else, right? So only 1 and 19 are factor of 19. So that means there are only 2 factors in the number 19. So it is a prime or composite? It is a prime number. Okay, So let's discuss this question that came out in 2019 paper 1 question 4 O-level mathematics. Part A, express 360 as a product of its prime factors. Okay, so let's see if we express. Okay, we write down 360. Now the question wants it in terms of the product of its prime factors. Okay, so is 360 a prime number? I mean, from the look of it, no, right? There seems to be it seems to be divisible not only by 1 and itself, but also other numbers, right? So let's check what is the smallest number, what is the smallest prime number that is divisible into 360 without a remainder. 2, right? So if it is divided by 2, we get 180. Now, is 180 divisible by 2 as well? Yes, right? So it's not a prime number, and we get 90 over here. Is it divisible by 290? Yes, right? To get 45. How about 45? Is it divisible by 2? No. What is the smallest prime number that is divisible into 45 without a remainder? 3, right? And then now we got 15. 15. And is 15 divisible by 3? Yes, we get 5. Is 5 a prime number? Yes, it is a prime number, right? So that is our last factor over here. So if you were to present it as what the question wants, how will you present it? You will say 360 equal to 2 power of what? How many 2 are there? 1, 2, 3. 2 power of 3, right? Multiply by how many 3, the next prime number. What is the factor of 3 here? 1, 2. So 3 power of, okay, let me just use the same color so that it is clearer. Three, and there are two trees over here, so that's why it is a power of 2, and we multiply by last one is 5, right? And 5 is with power of 1, okay? But we usually don't write the power if it is just 1, so we just represent it like that. All right? Okay, so the next question, the next part is part B. Okay, and part B said the number 360p over q is a perfect cube. Okay, so let's first clarify what is a perfect cube. What is a perfect cube? Perfect cube is a number where the powers of all its prime factors have to be multiples of 3, right? So let me just write it down. Power of all its prime factors have to be multiples of 3. Okay, so so let's look at an example. So for example, the number 8. Okay, is this a perfect cube? Let's see, is it what is the smallest prime number that can be divided into 8? 2, right? And if we put it 2 power of 3, we get 8, right? So that means this is a perfect cube. All right, how about 9? Is 9 a perfect cube? The smallest prime number is 3, and the smallest prime number factor is 3, and the power, it seems to be 2, right? 3 times 3 equal to 9. So is this a perfect cube? No, right? This is 9 is not a perfect cube, but 8 is a perfect cube. Okay, so let's erase this and come back to the question. Okay, so now they're asking for this 360p over q, and they want this to be a perfect cube. Okay, and early on we get the prime factors of 360, right, which is 2 power of 3 multiplied by 3 power of 2 multiplied by 5, right? And now we have additional, we have p, and we also have q. Okay, so early on we have defined what is a perfect cube, and if you look at over here, you see that 2 already has a power of 3, right? So that means we don't have to do anything with this, right? Because it already fits into the definition. But how about the prime factor 3? It has power of 2. So it means we have to do something about it, right? Either we eliminate 3 power of 2 at all, right? Or otherwise we'll multiply by another 3 in order to make it into a power of 3. Then this fits into the definition of perfect cube. Okay, how about 5? Okay, 5, this one only has a power of 1. So either we multiply it by another 5 with power of 2, so that to make this into a 5 power of 3, or we divide it by 5, so that this prime factor will be cancelled out, right? And we will just left with factors that is a perfect cube. So if we look at it, I think the easiest way, and you will have find out about this as well. If you look and think about it for some time, you realize that actually, the easiest way perhaps is to convert p into a tree, right? If we convert this into a tree, and we multiply it by a 3 power of 2, we get a 3 power of 3, right? And q, if we make this equal to 5, and we divide it into the 5 on the numerator, we will get a 5 power of 0. And a 5 power of 0 is essentially equal to 1. We don't have to write that down, right? So if we do that, and let's just try and see whether it actually works out or not. So we get 2 power of 3 multiply, okay, let me just use rate. Get 2 power of 3 multiply by 3 power of 2 multiply by 3, we get power of 3, right? And then we multiply by 5 power of 5, which is essentially this one is equal to 1, right? So if it is just equal to 1, we usually don't write it down, okay? And so we get this 2 power of 3 multiplied by 3 power of 3, okay? And we see that the factors of the prime numbers written here all have powers of 3. So this then becomes a perfect cube. So the answer for the value of p is 3, okay? And the answer for the value of q is 5. All right?